Hey, what's up, everyone? We're going to look at Chapter 5. It's called the definite integral. It goes over, there it is, the definite interval. This is page, integral. This is page 263. You guys should just start this over, huh? And we're starting here in section 5.1. So just a little thing here at the bottom of the page, talking about velocity and time, and we're actually going to do a little bit of that. So let me go ahead and get some paper out here, and we can chat about this a little bit. So let's say this is section 5.1. 5.1, the definite integral. Okay, and let's say you are running and you run at 5 miles per hour for 3 hours. Let's make a graph of this, and this graph is going to be very boring. Very boring. So let's see. Here is a graph. This is time, and this is velocity. Okay, so velocity is 5. It is constant. It is not changing. Time, 1, 2, 3 hours. So you're running for 5 miles an hour for 3 hours. There is my graph. Very boring. Okay. Let's also note this friend of ours, the dirt formula, D-I-R-T, put the I on its side. Distance is rate times time. I always just call it the dirt formula because it kind of looks like dirt. And one thing that we can kind of derive here, velocity and rate are the same thing. Okay. Yes, sorry. So, oh man, I just had a brain fart. So yeah, distance is rate times time. So if we take the rate, which is 5, and the time, which is 3, well, 5 times 3 is 15. 15. 5 times 3 is 15 miles. This is how far. This is the distance, is rate times time. One thing that I have here, I have velocity and time. What if I consider the area here under the curve? What if I consider this area right there? Well, let's see. This side is 3 and this side is 5. Obviously not drawn to scale. So the area is 15. And it's no coincidence that the distance and the area under the curve are the same. So if I have a velocity and time graph and I find the area under that curve, that will give me the distance. So let's consider a different problem, something a little more interesting. Let's say I'm driving at X miles per hour for, oh, I don't know, 10 hours. So you know, once X miles an hour. So let's say at 5 hours. I'm going 5 miles per hour. Okay, so the number of hours is the same as the velocity. So my graph is going to be a little more interesting. Okay, so at 0, it's 0. At 1, it's 1. At 2, it's 2. At 3, and so on, all the way up to 10. So this is my graph. Okay, so this is rate, time. So how far did I go? We'll just find the area under the curve, and it's a little bit of a different shape, but we can do that, right? We can do a triangle. So the base is 10, the height is 10. So area equals 1/2 base times height. Area. Well, we can call this the distance, right? The distance is 1/2. 10 times 10, so that is the distance is 50. Okay, so again, so if I drive at X miles an hour for 10 hours, I'll go 50 miles. Okay, so if I have any graph with the rate and the time, and I find the area underneath the curve, that will give me the distance. Whoops.